Hello, Pawan, you are there?
Yeah, yes, sir.
Okay. So today we'll start. Today we'll see on hypothesis testing. Okay.
Yeah, okay.
Okay. Let's begin. Okay. So this is hypothesis testing is part of actually the inferential statistics. Okay. So this is one of the very important concept that we come across in statistics. Okay. So today this is my agenda. So we'll discuss on to get an understanding on what is hypothesis testing, basically what is hypothesis and what is hypothesis testing. Then in statistics, usually how we conduct the hypothesis testing. Then we'll see examples. Pawan, you have any idea about this hypothesis testing? Have you come across, or at least since you are already you have certain knowledge in this the field?
Yeah, yes, sir. I have some basic knowledge of
Yeah, what you know? Can you explain me what it is?
for information statistics for
Hmm? You have worked on, see, you have come across, right? Means that what knowledge you have in hypothesis testing.
yeah, I have some basic concept like null hypothesis.
Mhm. Okay, it means the, so at least you know the words like what it comes. Means what is the fundamental of that, why you want, and why actually we use it. Okay, fine. So I'll just briefly explain about hypothesis testing. Okay, let's take an example. See, a person is on a trial for a criminal offense, and the judge needs to provide a verdict on this case. So, generally, what happens? See, there are suppose think that there is a person, and let's assume that he has done a crime. He has done a crime, and what generally in our particular law, what happens? The police actually they arrest this person, and they collect the evidence that he has done the crime. Means that they are doing they are collecting the evidence against the his innocency, proving that he is guilty. Okay, so now what they will do with this evidence, they will produce him to the court. The police cannot make any judgment on the person. Okay, so their duty is only to arrest the person, and they collect the evidence, then they produce to the court. In a court, what happens? So what is the default theory in the court? Any person is innocent until he is proved guilty. So that is the default behavior. Okay, so you take any person, he might have done anything. For example, in the recently in 26/11 also, what had happened, everyone knows that Kasab was actually in the videos, everything you had seen, that he was a person. Okay, for the so much of thing to happen. But so what generally they will do, they will collect a lot of evidence on that, then they will bring it to the court. In the court, actually, they need to prove that that person is a guilty. Okay, so that is the idea. So what is happening here? By default, we are saying something. By default means that a person is a person is innocent until proved guilty. once. Okay. English mod. English ಇದ್ರಾಗ ಇರ್ಬೇಕಲ್ಲ. One second. ಇಲ್ಲಿದೆ. Learn and write question 3. Complete the sentences given in the activity book, page number 30 one time. 30. Huh. Okay, thank you, Papa. Okay. 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 Sorry. Yeah. Now what is happening here in the verdict? Okay. So means that now once the police they produce him to the court with the evidence. Now what the judge will do generally? Okay. He will evaluate the evidences against to the against to the a person whether he is done the crime or not. Based on that he will make the decision. Okay, so that is a simple process. So this is what happens in the law. Okay, so here, so how it is going to relate to our hypothesis testing now? How it is going to relate to the hypothesis testing? So what is happening here? Actually the judge who is sitting here, he is performing the hypothesis testing. Okay, means that there is certain hypothesis is made. Certain hypothesis is made. What is that hypothesis is made? The police, they are saying that he is a crime and they have come with an evidence. Means that he has done a crime is an hypothesis. Okay, so based on that particular for that hypothesis, you need to prove the evidence. Okay, you need to have the certain proofs for that to say that. Okay, but again, it see again there are two things here. One second. Okay, so now in this case we have made certain claim. Okay, so we have made certain claim and that particular claim has to be proved. Okay, so that is a concept. Means that how we are proving that? Probably what we do, we take all the evidences and we are going to test the hypothesis and come to the conclusion that whether what is the conclusion on that particular person, whether he has done the crime or not. So all this decision will be done by the judge. And one more point you have to remember here. For example, now think that there are three judges are here. So take different three judges. Okay, so see, based on the evidence, the same evidence is given to this person. The same evidence is given to this person. The same evidences are given to this person. Okay, what is that innocence? The first claim we have made, there's coming with he has done the crime. Okay, for that crime these people have given the evidences, right? So what happens here? The judge number one, judge number two, and judge number three. Okay, and what happens here? See, the decision of the judge one could be different. The decision about the judge, if you take the individually, I'm saying. Okay, so why that the differences would arise here? That is because of probably their experience, probably their intellectuality. There will be many stuffs, right? So their decisions are different here. The decisions won't be different, maybe same in a few cases. Okay, so but there should be certain criteria here to make the decision. Okay, and what happens is there in when you this is about the generality. Okay, that is the reason what happens. Suppose in the district court, if something doesn't happen, then we take the things to the next level, the higher court. Okay, so for the better decision. Okay, for example, think that if the person is innocent but the decision has come against to him, so people generally they will take it to the higher court again, they'll fight for the case. Okay, it means that they are not satisfied with the judgment. How this person has judged it based on the evidence. Probably, see what happens. The evidence what is has given, probably it would be less, or they may not have given the full proper evidences or against to him or for him. Okay, so all that permutation combinations will work over here. Okay, but when it comes to the statistics, okay, so in our statistical world, we need to perform this hypothesis testing. Okay, one second. Okay, fine. This is about hypothesis testing. Even I can give one more example. For example, you can say, think that, yeah, in my office, I was just checking how to reduce the weight. For example, now that one person was telling me, okay, if you eat lot of vegetables, if you eat lot of vegetables, automatically your weight will get reduced. Okay, so I can take this as a claim actually. Okay, means that we don't have any proofs for this. Generally, when when I made this particular hypothesis statement, then I have to go and cross check this. Means that I need to create my own data for that, probably for certain samples. I would have few numbers. Then for that, whether completely eating the vegetables, okay. So what is the result? The based on that. So again, this will become a sample, and this particular statement, the claim what is being made, that is for the population. Okay, but ultimately we cannot test it on a population. We can always do it on our samples. Okay, and what is happening? Mainly this hypothesis testing. What we are doing, the statement or the claim made for the population, we are going to test it on the statistics. Okay, the results what we get it from the hypothesis testing, we are going to infer it to the population. Okay, so that is the idea. And see here, for example, see the same statement which I can tell you that simple. Okay, so the hypothesis testing, okay, it is used to infer the result. Okay, infer the result of the hypothesis performed on a sample data from a population. Okay, so this is very simple. And this hypothesis testing, let us see that how we perform it in a statistics. Let's take the same case like in a hypothesis testing. See, when you take this the same case, there are four possibilities are there here. Okay, the one possibility is that the a person can be innocent and the judgment can be innocent. A person can be innocent and the judgment could be guilty. The person can be guilty, but the judgment is an innocent. Guilty and a guilty. Okay, if you see this, there are only two situations which are actually correct, and these two in between two situations are actually incorrect. Okay, yeah, so these only the four situations that could exist in the court. Okay, even if you take in our statistics, see there could be only two events, okay, A and B, and again the combination if you see this is AB or BA, AA, and BB. Only these four situations could exist even in our case also. Okay, so now we need to discuss mainly on this, because always what happens, we are going to test it for this particular sample statistic. Okay, and the claim is happening on the population parameters. Fine. So if you take this, the presumption already have made, the person is considered innocent until the proven guilty. And if you put it something like a diagram, so how it actually says, the judge says innocent and the guilty. What is the reality? The innocent and guilty. If you plot it, there is no error, because the person is innocent and he is also, the judgment is an innocent. The person is guilty, but again the judge is also guilty, but here also no error. And there is a mistake happening when person is innocent but you are seeing guilty. So now this type of error we call as a type 1 error, and this is a type 2 error. Okay, so in our statistics, okay, what we can say, so this we call as an alpha, actually the significance level alpha. So I'll come back to this. Yeah, the null hypothesis, see, we make certain statement, because before coming to the null hypothesis, we always believe that certain thing is true to us, like this can true until we found sound evidence it. Okay, means that by default when the person is taken to the court, he is innocent. We cannot say he is a guilty, as I gave the example for the 26 bar 11 what it happened. Okay, so I just give an example. By default he's an, whatever he had done, by default he's an innocent. So that is the null hypothesis. Null hypothesis, and our job is only that we have to make this. Okay, this we have to make this we need to reject the null hypothesis, means that by providing the sufficient evidences against to it, saying that this is wrong and coming to our alternate hypothesis what is correct as to us. Okay, means that if it is here in innocent, then this will be here non-innocent, means that that is a guilty. That is the job of the hypothesis testing. You make the null hypothesis, you create certain claim on that. So what is the default thing? You provide the evidences to that, saying that we need to reject this null hypothesis and we accept what is for the alternative. Okay, so that thing what we have written here. This can be true until we find a strong evidence to it. And there is a significance level. Okay, just 1 second, please. Okay, so this significance level, I'll tell you, this is an interesting thing. Okay, see, for example, I will give a better example here to understand the significance level. See, there is a judge here. Okay, so there is a judge, and for this person, the police has given certain evidences to him. Okay, now it's a job of the judge to take a decision based on the evidence. Okay, means that what this police have done, see, they are coming as an alternative hypothesis. What is the default? He's already innocent. Okay, and why they are providing evidences? Because they want to disprove the null hypothesis and asking the judge to accept the alternative. Okay, so that is one part. So here what happens here, one situation could exist. For example, in some situation what we'll generally call, like we'll talk about actually who is a judge. Okay, so the judge could be very strict or he can be little very casual. Let's take two cases here. Okay, so this guy is a very strict and this guy is a very casual. Okay, what once this we bring these evidences, our feeling is that, oh, this strict person purely cross check all the evidences, then he may give the result. What about the casual person? He'll casually look into the evidences, then he can give his result. Okay, so how do you actually evaluate that whether this guy is a strict or whether he's a casual? Probably what happens? Okay, probably what happens? In his mind, there is certain criteria. Okay, there is a criteria. Probably what we say. With that criteria we may say that, so he might be strict. Let's assume that I will define certain a alpha as the criteria here, alpha. Okay, means that if the alpha value is very 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 small for me, okay, if the alpha value, see the kind of decision this guy is taking here, I will just measure with the help of alpha. Okay, now I can say that, hey, this guy's alpha is very less here and this alpha guy is a very more for the casual person. It means that, okay, so this guy, okay, this guy, when the alpha is more, it means that I have to come up with lots and lots of evidences to prove that this person is guilty. But in this case, when the alpha is more, okay, means that I need to have less proofs here, even the evidences. In that case, what happens? This guy is chances of making error is more, but whereas this guy is making the chances of taking the decision is very the chances is very good actually if you take this person, because he's already strict and he's evaluating each and every proofs of the evidences. Then what he is taking the decision. So that particular criteria, how they measure, if I can call this as an alpha here, okay, means that I can, if I have a chance, anyway these are human beings, right? So now in this in our statistical world, I have an opportunity here, means that I can fine tune this value. For example, mm, now I can set the value something like a zero point 0.5 or 1, okay, or 0.05, or I can give certain percentage. Means that if the percentage as it is become lesser and lesser, means that I need to have more evidences to prove that the null hypothesis is incorrect. Okay, and if the alpha is little greater, then the automatically my evidences will become little lesser, and I may move towards more on the error part. Okay, so that you have to remember. Okay, so that is the understanding on the significance level. And this can, in the statistic or in a probability, this can be said something like the probability of a judge decide guilty against a person is innocent. Okay, so this need not no worry about this, but just understand, if alpha is smaller, it will require more evidence to reject the null hypothesis. Thus in the same case, my judge is very strict. Okay, that is the reason I have given him value as a very small. This person is very casual, they'll, okay, the alpha is more and probably he may make more errors here. Okay, but when the alpha is less, the evidences have to be more here. Okay, yeah. Okay, now if you take the diagram similarly, a type 1 error is the alpha. Type 1 is the error is alpha, and this is 1 minus 1. See, type 1 error, I'm setting certain value for this. I said like I want to give certain percentage like 5% or 10% or 1. Means that I'm okay with having the 5% of the error that guy is making. Okay, the judge is making. I'm okay with that. Okay, but at least another, if you see this, if I'm okay with 5% of the error, the remaining 95% is there for me to accept it. Okay, suppose reduce this if I reduce this, automatically what happens? I need to provide more evidence to that. Okay. So meaning that if I see this as a probability of giving a judgment that a guilty when the innocence is given. Okay. So if you take this, in my case, okay, what is this G bar I? Okay. So if I just go back and say this, that is nothing but your the type one. Okay. So means that I need to if I have a smaller values, my probability has to be okay, means that the judgment what you have to give, so like it will be the evidences which I need to give, that has to be little more here. Okay, so that is the understanding of the hypothesis testing, and you'll better understand if you solve certain problems on that. Okay, okay, let's take this hypothesis testing steps. Generally there are only 4 steps which we generally follow when we want to perform any kind of hypothesis testing in the statistical world. Okay, so first you need to set the hypothesis. When the problem is given to us, you need to find out what is the null hypothesis and what is your alternative hypothesis. Okay, so in this case, null hypothesis and alternative hypothesis. I will come back to this null and alternative hypothesis. Then I need to set the significance level and criteria for a decision. So what is your alpha value? Means that you are okay with kind of error. That's what we want to say. Like it will be a 1%, 5%, 10%, something like that. Okay. And then what we have to do? We have to compute the test statistic. What do you mean the test statistic? You can understand something like our judge is sitting here and the evidence is given to him. What he will do, he will evaluate everything and he will give certain value here, that I call is at a test statistic. Okay, that is a measurable thing. Okay, and here this person probably with his experience, he will evaluate everything and he definitely he will summarize and think that, so this is the right thing, right? Okay, so that particular value, if you see this in the real world, okay, in the statistic, I need to measure those things, that we call as a test statistic. Then after that, based on these values, the make a decision. Simple. Okay, so these are the 4 basic steps. State the hypothesis, and this hypothesis statement will be for the population. Then you need to define the alpha, that is the significance level. Then after this, you just compute the test statistics. See, for the population, you have taken the sample, you are computing the test statistics for the sample, then you make the decision, okay, on the p-value to what is, whether you are going to reject the null hypothesis or whether you are going to accept the alternate hypothesis. Okay. Okay. Now, if you take this as a court example only, okay, let's set up the hypothesis as a null and alternate. Okay. So means that when in the court session, as I the innocent, the any person, okay, any person is innocent until his proves guilty. It means that the null hypothesis is that innocent. Okay. So that is first thing. So keep in mind that only reason, see, we are testing the null hypothesis is that we think it is wrong. Okay. So why actually we want to do hypothesis? Because we want to, we have a doubt on the null hypothesis. That is the reason we are going to test it. Okay. If we don't provide the evidences, then automatically null hypothesis will be true. Because, for example, even if he has done a crime, then if you don't provide any evidences against him, then obviously then he will be innocent and will be free from the court process. Okay. So, and this is about null hypothesis. And null hypothesis is always represented H0, and the alternate hypothesis represent as an H1. Okay. Yeah. And here the H1 is that the defendant is not innocent, means he is guilty. Okay. That is what your H1 is saying. Okay. Then the set the level of significance here. Okay. To test the criteria for a decision, we state the level of significance for a test. Okay. As I said, there could be 5%, 1%, or even 0.5%. And this based on the level of significance, we can make the decision on the null and alternative hypothesis. Then we are going to perform the computing test statistics, as I told you. So this is mainly what we calculate is that the probability, okay, has a higher likelihood and has enough evidence to accept the null hypothesis. Okay, the test statistics is nothing but, you know, the meaning of the statistics. Okay, why we are calling it a statistics? Because, you know, this is your population and this is your sample we call as a statistics, and population we call as a parameter. Okay, the test statistics, because we are going to evaluate the evidences what is available with this, then we are going to compute the test statistics, and based on the value of the test statistic we are making the decision. Okay, so that is a beauty. Then based on the test static, we make the decision. Okay, so here the probability what we calculate, for example, now already have set the alpha. If my p value means this is the output of the test statistic, if the p value is less than alpha, then we reject the null hypothesis. Simple. Suppose if the p is greater than alpha, then we are going to we are going to accept the null hypothesis. In rather, we would mainly say that we are failed to reject. Actually, we never call it as accepting the null hypothesis, because we are actually failed to reject that. Okay, because our obvious choice means that our obvious point is that here in the hypothesis testing, we are into this hypothesis only because we have a doubt on the null hypothesis. That is the reason we are going for testing it. When I don't have an evidence, okay, when I don't have a proper evidence, I don't have the proper statistical figures with me, where I don't have the knowledge where I can prove that the null hypothesis is wrong. Okay, so that is the reason obviously I need to accept it. So rather I would say accepting, I would say that we are failed to reject the null hypothesis. Fine. Let's take an example and we'll explain more on this. See here, there is a telecom service provider and he claims that the individual customers pay on average 400 rupees per month. Okay, so what he's saying that, so he's saying he's just making a claim. Okay, so he's saying that the individual customers, individual take any of the customers, and they are actually paying on average of 400 rupees per month. 400 rupees per month, his claim. Okay, that is his claim, with standard deviation of 25 rupees. Now what we'll do, a random sample of 50 customers bills during the given month is taken with a mean of 250 and standard deviation of 15. If you see this data, so what is all given to us? means that these are the evidences now I need to build, right? So evidences means what figures are given, and still more, if I want to calculate something after having all the evidences, take that evidences, then you can calculate the test statistics, and from the test statistic you are going to calculate the p value. From the p value, the decide what is already have set a significance level, whether it could be 5%, 10%, or lesser than that. So based on that, make a decision whether you need to reject the null hypothesis, or you are means that you are failed to reject the null hypothesis. There could be only two situations here. Okay. Now in this case, what happens here? What are my given parameters for me? See, mu is already given. So that is we are saying that. So mu is already given. Like this is a 400 rupees per month. Okay. So the mu is 400. Then my standard of deviation for the population is 25. Okay. So with the standard of deviation, I'm saying it is 25 rupees here. And n is 50 here. Okay. N is 50. And a given month. And my x bar will be 250. And the standard of deviation is equal to 15. Okay, so these are my given values. If you see this, okay, these are all my given values. Good. Then I have so much of data. Then I definitely, now next level is that I need to just set my alpha here. Okay, so what is my alpha for a significance level? No, but before that, I need to go define my what is my null hypothesis and what will be my alternative hypothesis. If you see this, what will be my null hypothesis? The null hypothesis, what he is saying that the customer pay on average of 400 rupees, means that the average, that is a mean value of the population. I'm saying this is my parameter, and I'm saying that is equal to 400. That is my default null hypothesis. Okay, now what we have to do, you have to disprove this, whether are they really paying on average of 400 rupees per month or not. So that is a question. And if I want to answer that question, I have to follow the process of hypothesis testing by collecting certain samples and evaluating the test statistic. Okay, so now this will be, because always these are contradicting statements, means that they are totally against each other, as I earlier stated. Okay, the null hypothesis, if you take the set theory here, okay, if you say this is your null hypothesis and there will not be any interaction, okay, the completely alternate hypothesis will be different set altogether. Okay, so this is nut and this is a. Now if I say this is a 400 and the complement of it, okay, what is a complement? Sorry, this won't be a, this is a complement. U is not equal to 400. Okay, so that is my alternative hypothesis. Okay, now this much of data is I have already given, and this is for my population, and this is for my sample. Then sample size already given. Now I have set it as a 5%. Alpha is my 5%. 5% means this is 0.05. That is a value. Okay, good. Now let's calculate the Z statistic. Here the Z statistic, you see, Z statistic means we are going to there is a Z test is a tool, actually a statistical tool. Okay, so that is used for hypothesis testing, and I'm just directly going to the Z statistic here. I will come back to this, but I want to just complete one example so that you'll get an idea. That is a question. Okay, so now what we are doing, see, now I have got all the evidences. Okay, now I have all the evidences and I have collected the data, so for my situation, and now I have to prove whether I need to go with the null hypothesis or whether I have to go with my alternative hypothesis. So in order to do this, I need to go for calculating my Z test. Okay, so Z test, what will do? The Z test actually derives a difference between two large population samples, provided the variance is already known to me. And this is very important. Okay, so if my population variance, that is sigma, if is already known, then I'm going for the Z test. Okay, and here this Z test something looks like something like this. Z is equal to the x bar is my sample mean minus the population mean divided by sigma root n. Okay, this is your standard error. Okay, we have already discussed in this earlier class. Okay, so this is x bar minus mean. Now what I will do, using this Z statistics, okay, I am going to calculate it. Okay, so you know this in the last class when I was explaining. Okay, So you know this, for the normal distribution, we are going to transform it to our standard normal, where the mean is 0 and the your standard of deviation is 1. Okay, so where in this, actually, when you were discussing about normal, we had calculated the z score. Okay, and here when I do this, actually, I'm standardizing my data. Okay, I am just standardizing my data. What you are standardizing, the mean value of the sample, we are going to standardize it, and considering my deviation error, I'm just comparing with my, I'm calculating actually where I lie into my the standard normal distribution. Okay, so let's calculate the Z test. If you see the Z test, I'll just put all my values here. I get it around minus 42.4.2. Okay. Okay. Now with this value, what I have to do? What I have to decide? Okay. Let's see. So this I have already calculated. This is what I have got it. There are three figures which I have given to you. Okay. So let's take a look here. In my normal distribution, in my standard normal distribution, okay, this is how my graphs will look like. Okay. When I say a alpha is equal to 5%, now what happens here? My rejection, okay, when my rejection will become here the tail. Okay, whenever my z score falls somewhere here, then I'm going to reject it. So alpha by 2, because this is the area actually. If I say 5% here, means that take out the 95%. 95%, what is 1 minus alpha? That is the what you are going to accept it. Then what is left out is here, there are two areas. Okay, now this we call as a two-tailed test here, means that there are two tails where I'm going to test it. In some of the cases, we'll be evaluating only on one side, either in the left side or a right side, so that we call as a left and right tail test. Okay, so in this case, my alpha is getting divided into two parts, that is 2.5 and the 2.5. When I calculate my Z score, okay, from the Z value, I need to go back to my Z table and calculate how much the value I will get it. Okay, so whether it falls in the which of the region, okay, this region. So based on that, I will take a case. Okay, if you see this normal distribution, so this is empirical rule what we had discussed in earlier class. So 68%, 95%, 99.7. So this based on the number of standard deviation, how much area we are going to cover. So that is the idea of the normal standard normal distribution. Okay, so the same figure when I take it, now what happens here? So this will be my rejecting is 2.5%. This rejecting is 2.5%, and this is what you are going to accept it. Now this will become the yellow, the blue lines are nothing but your critical regions. Okay, so it means we call as a boundary. Now, what is my value? If I go back and check the calculated Z, okay. So actually this is less than 1.96. Why it is 1.96? See, this is and this is 2.5% and this is 2.5%. This particular border is there. Okay, so that is 1.96 and 1.96. These values are coming already from the defined data, and also you can calculate using your z table also. Okay, so now what is happening, the calculate is minus 4.2, so which is actually very very lesser than the minus 1.96. So it means that this particular our value what you calculate is going and falling in the rejection region. Okay, so that is in the negative part. So that is the reason what we are going to reject this null hypothesis. That is the idea. Okay, so that is the decision what you have taken now. For this z test, if I go back and check my the table, okay, so that from that we'll get the p value. If the p value, what is happening here, my p value is actually going to less than alpha. Okay, that is the reason we are going to reject it. Fine. Now what is happening here, we are discussing on the critical regions. Okay, critical region in hypothesis testing, the critical region is represented by set of values where null hypothesis is rejected. Okay, so here these are my critical regions. Okay, so these are coming from our standard normal. Okay, so based on the different the parameters, for example, now I would consider 95% acceptance, obviously 5% rejection. If I say 97%, a 3%. Okay, so based on my z score I will have a different boundaries altogether. Okay, so what is the idea here? Your significance level, what you're setting is important. If I set as a 5% and extra points will be 95%, based on these values I'm going to calculate these value, because these values are already calculated and kept, because these won't change. What you have to do, you have to go and check your z score table and you will get all these values. Okay, and is known as a rejection. Okay, it takes a different boundary for a different level of significance. That's what I told. Now if you set alpha is equal to a 5%, a alpha is equal to 10%, or alpha is equal to 1%, so based on these values my rejection, the critical regions will change. Let us see that in one of the figure. I'll show you that. Okay, now see this. This is a critical regions in hypothesis testing. This is 1%, this is 5%, this is 10%. Again it depends upon your choice. When you're trying to solve the problem, if the problem is already they have given that you take the level of significance as 5%, then no problem. Even if they are not given, it is your choice that what you have to choose, and based on that what significance level is chosen. So from that idea, so you have these values as the critical region boundaries. Okay, okay, then whatever you calculate your z statistics. Okay, so ultimately you need to evaluate actually where it falls. If I consider for the level of 1% here, then here minus 2.58 plus 2.58. If you take this is minus 2.58 plus 2.5. If my z value lies here, or if it lies, then I'm going to reject the null hypothesis. Okay, so if I go with the right tail test here, so it will be plus 2.33 here, whatever here. Okay, so same thing. Similarly, this one, this is for similarly, if you are going for 5%, this value, and 10% here, these values. Okay, let's take the Z and T tests. So here in the Z test, when I'm performing, so there are two things which we come across. Comparing the sample mean with the population mean means that earlier also what is happening here, the mu I'm just comparing with the sample mean. Okay, so comparing a sample mean with a population mean. So that was the example which I looked into the last exercise. Then we have the comparing the mean of the two samples. Okay, there could be two samples, and I want to, there is certain hypothesis statement is made on those two means. Then I need to evaluate whether are we right, we are with the null hypothesis or not. Okay, similarly we have a t test. Okay, so why this t test is required? That is basically because if the if the number of samples are more, then we generally take the z test. Or if the number of samples are less, okay, then the population variance is not available with this. Only those two conditions. Then we are going to go with the t test. Okay, and here z test, you know this, that is the normal distribution which everywhere you see this graph 68, 90, 95 and 97.7. Okay, so this is a standard, your standard normal distribution curve, which is like bell curve. Similarly, you have the t distribution, and it is more like a similar to your standard normal, but still variations is there, which we will discuss that. And again for this curve also already all the values are calculated and it is available as a t distribution table. Here also everything is calculated and kept as a table called a z score distribution table. Okay, and for all your hypothesis testing you are going to use those tables for calculating for whether we need to take the decision on how you to make it on whether null hypothesis to be accepted or rejected. Okay, so now if I take the consider of one sample z test. Okay, one sample test is, this is the formula what I have to apply, and one sample test is mainly used for comparing the sample mean and the population mean. Just remember SP. Okay, sample mean and population mean. What is happening here? What you see, the sample mean is here and the population mean is here, and z score is how we have calculated. The same formula I applied in the last exercise, and in the last exercise what I was doing, so the mean was something equal to 400 I was doing. Okay, so means that what I'm trying to do here, I'm just comparing my sample mean with the population mean. Okay, so here this was my population mean, Then in the I am cross checking whether are we with the null hypothesis or not. Means that I am trying to compare the sample mean with my population mean using the one sample Z test. Okay, let's take one simple example here. Let us say we need to determine if the girls on average score higher than 600 in the exam. Means that the mu value is there. Okay, mu value is there, and girls on a score higher than 600. This is higher than 600. Okay, we have the information that standard deviation of the girl's score is 100. It means that when the sigma is given to me, then I have to perform the Z test. Sigma is equal to 100. So we collect the data of 20. Here already 20 samples are given by using the random samples and record their marks. From using this value, what all I can calculate? One is n I can calculate from this. Okay, the number of samples. Then given the the sample mean also I can calculate. Then even I can calculate the sigma x also. That is the standard deviation of the sample. Now all these values I can calculate it. Now if you see this, I need to define the hypothesis now. Okay, so now if I say mu is greater than 600, then mu is one more point I can write. Mu is less than or equal to 600 because I want to have two statements here. Okay, so means that one is should be your null hypothesis, and the remaining complement will be your alternate hypothesis. If I say one, if a girl's on average score higher than, if this is my statement, the other statement will be less than or equal to 600. Okay, fine. But in this, which is null hypothesis and alternative hypothesis? One very interesting. See, always in the null hypothesis, the equal sign exists. Okay, that you have to remember. So if this is a equal sign, then this will be become my null hypothesis, and this will be become my alternative hypothesis. Okay, yeah. Now that's what we have said. Null statement is always contain some form of equality here. Okay, otherwise in alternative hypothesis not equal to, greater than, or less than, these only exist here. Okay, yeah. Now with this data, we are able to define our null hypothesis and alternative hypothesis. Fine. Now what happens? I can decide whether it is a left side test or right tail test only from your alternative hypothesis. Now it is showing in a right side means that I have to test the right side. Okay, the right tail test. Okay, fine. Now what is the data is given? Already have given my data here. So means that from the data sampling points, what I have already given it here. So I have already calculated that is x bar is 641 and n is equal to 20, and significance level is 5%. Fine. Now using this data, now I'll go and calculate my Z test. Okay, I'll just put all the values, and this is my 1.8336. If you see this, what is my significance level? The 5%. Okay, and this is 1.8336. If you see this, 1.8 is here. This is, and it's a right tail test. Okay, that is 1.6. If you see this, 1.8 is greater than to me. Okay, now if I just go and see this in the regions, if you see this, and this is my mean, sorry, if I see this is my mean, and this is the right tail test. Okay, so this is only in the right tail test, only one critical region exists. Okay, now what is the critical value here? Critical value is 1.6. Okay, now if you see 1.8 means after 1.6 somewhere it is falling here. It means that it is going and falling in your critical region. Okay, if it is critical region, then we are going to reject the null hypothesis. So that is the conclusion. Okay, and if you see this, yeah, Z and falls in the critical region, and the we can calculate the probability also. How we can calculate probability? In the last class, I discussed about how to calculate a probability based on your Z score table. So what you have to do, you just go back and check what is 1.8, and then you just go to the column 0.0, uh, 0.03, okay, then that particular value is nothing but your uh, the probability value for this one. Then since it is coming on the left side, okay, because if you see this graph something like this, so this is in the right side. So now you are going to calculate, because this completely area is 1, and up to this much you have calculated the probability. What is this probability? That is nothing but 1 minus what is calculated here. Okay, so that's what we are doing. So that is 0.033. Okay, now if you take this 0.03, and again this is less than your 0.05. When it is less than 0.5, what is the result? We need to go and reject the null hypothesis. Simple. Okay, then coming to the two sample Z test, and we perform this two sample Z test when we want to compare a mean of two samples. Okay, so there are two samples where we need to, again this formula is the same approach. Okay, the only the formula will change here, and what we are trying to do, we want to compare the mean of two samples. Okay, let us say we want to know if the girls on average score 10 marks more than the boys. 1 second. Yep. ಮತ್ತೆ ಇಷ್ಟೊತ್ತಲ್ಲಿ ಟಿವಿ ನೋಡೋದಿತ್ತಲ್ಲ ಅಲ್ಲಿ ನಿಮಗೆ ಇಲ್ಲ ಅನ್ಕೋತೀನಿ ಟಿವಿ ಆಯ್ತು ಮುಗಿತು ಕ್ಲಾಸ್ ಇನ್ನೊಂದು 10 ಮಿನಿಟ್ಸ್ ಮುಗಿಸ್ಬೇಕು ಚಾಲು ನಾವು ಮಾಡೋಣ ಕುಂತ ಮಾಡೋಣ ಜೊತೆ ಕುಂತ ಮಾಡ್ತೀನಿ ಕೆಲಸ ಮುಗಿತಲ್ಲ ಈಗ ನಿಂದ ಎಲ್ಲ ನಿಂದ. Okay, in the case of two sample Z test, so here we need to compare the means. Okay, the mean of two samples, that is the that when we want to compare it, then we are performing this particular hypothesis test. Okay, so here what we generally do, the let's take that girls on average score 10 marks more than the boys, means that there is an average score for the boys, there is an average score for the girls, and he's saying that their difference is greater than 10. Okay, if you see this, girls on average score 10 marks more than the boys. If I say from the population, if mu1 indicates girls and mu2 indicates boys, then mu1 minus mu2 should be more than the boys. So now this is greater than 10. So since it is a, there is not be any equal symbol, definitely this is your h1, and what will be your h0? So mu1 minus mu2 less than or equal to 10. So this will be, this is what you need to test it. Okay, yeah, so based on the data, so let's see what data is given to us. As I said, yeah, this is what we have defined your uh, the null hypothesis and alternate hypothesis based on the data. Okay, and again, so what is your alternative hypothesis saying? So this is right tail test again. Okay, so these are the scores what is given, the mean score for the girls, and we have already calculated, because from the data which I have already calculated, that is 641. Okay, the mean score of the boys, okay, sample mean 613, and this is your sample mean, and this is your sample mean. We have information. Okay, fine. Now the standard deviation of the population of the girls is 100, and which is already given. So standard deviation of the girls is 100, and the boy score is 90, and this is also given to me. Then the size of the is 20 for both and girls. The size remains the same, and the difference between the mean population is 10. Okay, that's what already the first statement given. Okay, so with this data, so let's go see, with this particular evidences, we need to build our statistic. Okay, so now okay, by default, let's take the level of significance be 0.5% only. Then I just take this formula and apply all my values, and this is the value what I get it. Okay, that is 0.588. Now that is a right tail test, that is a 5% significance level. If you see this 0.588, same thing here. Okay, this is a right tailed, and this is your 1.6, and again 1.6 means this guy, now the calculated value is less than 1.6. It means that we are actually failed to reject the null hypothesis. Okay, we fail to reject the null hypothesis, and we are going to accept the null hypothesis. That's how we calculate for the two sample Z test. Coming to the t test, So t-tests are a statistical way of testing the hypothesis when we do not know the population variance. As I told earlier also, if the one is the sample size, if the sample size is not large, okay, not large, maybe greater than 30, okay. If it is 30, then we go for a Z test. If it is less than that, then we go for the T test. Okay. And one more condition is that when you don't know the population variance. Yeah. So before this, we have to have an understanding of T distribution because already you know your standard normal curve, which we discussed in the last class. And now, but for the T test, at least we have to have an understanding on T distribution. And this T distribution, again, it is very similar to your standard normal curve, having the bell shaped, and again, you have a unimodal. Okay. And its symmetry is also around the T is equal to 0. If it is a Z, again you will have a Z is equal to 0. That is the mean value, and standard deviation will be 1. But here in this case, you don't know the standard deviation. Okay, so we say that obviously it will be greater than 1. Okay, the variance is greater than 1 always. This makes, okay, when it is greater than 1, here it is 1, but when it is greater than 1, it means that it won't be look something like this. Probably it will go little a flatten. Okay, and that is the reason it makes wider and flatten in the T distribution. Okay, and then the more area in the tails than the standard normal curve, because if it is a flatten, okay, if it is a flatten, then there will be more area in the tail, not like your normal distribution. Okay, if you see this graph, this dotted line is your normal distribution, this dotted line, and this particular the blue line is nothing but your, this is your T distribution, and this is your normal distribution. And if you see this is widely what I can see, it is flattened, and also is more wider than the normal. Probably what happens here in the tail part, you will have more lot of area. Okay, yeah, fine. See, in the T distribution, just like other distribution, has only one parameter, the degree of freedom. Here in the normal distribution, there is a mean and a standard of deviation. Okay, so based on these two parameters, we can have multiple the normal standard normal distributions. Okay, I can come up with any kind of, but how actually this particular T distribution is going to vary, and this is very going to vary by only one parameter, that is the what we call as the degree of freedom, that is called DF. And this DF is mainly nothing but your number of freedom refers to the number of independent observation. That is what the freedom refers to. For example, now you think that as we know already, when we are discussing about T means, obviously the number of samples would be less. Consider less than 30. If it is less than 30, what happens? Suppose think that I am working with the 10 is equal to 10 samples, then the total number of observation less than 1. That is n is equal to 10 minus 1. And this will be my the degree of freedom, that is 9. Okay, and based on the 9 only, based on my degree of freedom, my T distribution is going to vary. Okay, so let's see if I have any graph. Okay, I'll just show that. And the same example again, the 10 observation or elements would be analyzed in T distribution with a 9 degree of freedom. Okay, and here if similarly if there are 6 degree of freedom distribution, and the sample size would be 7 observations. Okay, because obviously in the T distribution we are always working with less than 30 observation, so all my figures whatever we discussed, that will be the number of observation will be less than 30, like 6, 10, and all that. Okay, now in this figure what is I'm trying to show you, these are different colors. Now if I start from, this is your 1 degree of freedom, this is a 3 degree of freedom, and see this particular distribution, definitely there is certain formula. If you see this in the Z score, I used to uh, I used to derive my Z score by having this, right? Okay, so Z minus sigma by n. Okay, so this was a formula which I was applying to calculate my Z score. But here there is again a formula for calculating my T distribution, and based on my number of observation, that is what the degree of freedom, I will have the different types of the T distributions. Okay, so formula for me is T is equal to x bar minus mu and sigma n. And here I'm using S here, not sigma, because I don't know the population deviation. So that is only the reason why we are switching to the t distributions. Okay. And one sample t-test will come back here now. Okay. So same thing here for one sample t-test when we want to compare the sample mean with the population mean. Earlier also in the Z t-test for one sample, what we are doing, see this particular one sample Z test is used because we want to compare the sample mean with the population mean. Okay, similar here also, only the case is that we have the less number of observation, and in this case we don't know the idea of the population variance. Okay, yeah. So let's take one example here. Okay, so here this is how we calculate it. So let's say that we want to determine if an average girl score is more than 600 in the exam, and we do not have the information related to variance. That's what we have said. Okay, and I'll just go back directly jump into this the score. This is how my null hypothesis and alternative hypothesis looks like. And again, if you see this, this is my the right tail test. And what I will do, I will set my significance level. Then after this, I will calculate my t-test. And what is the tweak here? Earlier, I was checking and evaluating for the critical regions for the Z distribution. Okay, but here not the case. We have to go back and check for the t distribution. Okay, now all this data is given to me and I will just apply it on my t-test and I calculate this 1.64. Now what I have done, I have just extracted the t-test table. Now this is 1.64. Let's take what is my number of observations. If you see this, the number of observations are 10. Okay, so now degree of freedom will be 10 minus 1, that is 9. Okay, now my table will be based on the degree of freedom. Okay, fine. Now this is your degree of freedom and this is the ninth. Okay, fine. Now what is my tail test here? If you see this, go and check my alternative hypothesis. That is the right tail test. So if I go and check this is my one tail test. Fine. In the one tail test, what is my significance level? That is 0.05. Okay, and where I see this 0.05, yeah, this is your 0.05, and what is the value here? That is 1.883, and this 1.883, what I have written, this is a critical value what I get it, and t score is less than the critical value. Okay, now this is your critical value and the t score somewhere appears over here. Okay, it means that we are failed to reject the null hypothesis. Okay, this is because it is falling in the acceptance region. If you take this is 8.33 and my value where it is falling 1.64, that is less than somewhere here. This is your acceptance region, alternative hypothesis. So that is the reason we fail to reject the null hypothesis and we don't have enough evidence to support the hypothesis. Okay, fine. So that's what we can conclude on this. Similarly, there is a two sample t-test and this is the formula what we apply it here. Okay, that is the same formula earlier what we are doing for, but this will be for the t-test now. And same thing, the same thing we need to carry out. I don't want to get into an example here. And but what is the criteria to choose between a Z test and a t-test? Okay, so if I want to decide this, that is purely based on your sample size. If the sample size is greater than 30, okay, if it is yes, then I can go for Z test or T test. Even you apply both the formulas, there could be values would be different, but ultimately the idea of whether rejecting a null hypothesis or accepting it, so the result will be the same for both Z test and T test when the sample size is greater than 30. And if a sample size is less than 30, and next criteria is we have to evaluate the population variance. If the population variance is unknown, then go for the t test. If it is known, then go for the Z test. Okay, simple. Yeah, that's it about this hypothesis testing. And I'll do one thing. I will upload one project for you, and I will give all the detailing and GitHub, and I will communicate that with you. Okay. Okay, fine. Pawan, any questions? Pawan, you are there?
No, sir. So I have done that outlier concept, sir. Can I
Yeah.
share it today, sir?
Yeah, you just share me that document. I'll just go through and again, if anything is there, or else you can do one thing. Share me, but at least is it possible that for half an hour you can just explain me what it is? That will be a practice
Yes.
for you.
Yes.
No, if you're interested, then I can give a lot of things because if you have written up for 5 pages, that can be extended for 10 pages, I'll tell you.
Yeah, okay, sure, sir.
Okay, means that you have written it and you have an idea what you have written, and probably you might be reading multiple times. At least when an interview is there, you can just say that this is a work what I had done in one of the project on the outlier detection. You can speak more on that content.
Yeah, okay, sir.
Okay, got it, huh?
Yeah, sir,
Okay.
got it, sir.
You do one thing, you share to me, I will just evaluate it, then again I will come back to you. Okay.
Okay, sir.
Okay, okay, fine then. Huh? Okay.